Hello, everyone, and welcome to today's SANS webcast, IDA Pro Challenge Walkthrough, and what's new in SEC760, Advanced Exploit Dev. My name is Jessica Gallus of SANS, and I will be moderating today's webcast. Today's featured speakers are Huáscar Tejeda, F2TC Cybersecurity, and Stephen Sims, Pen Test Curriculum Lead at SANS. If during the webcast you have any questions for Huáscar and Stephen, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Stephen.
Great, thanks Jessica, and hello everyone. Thanks for joining. You know, when we put together a webcast like this, you never know if you're going to get 5 people or 100 people, and it looks like we're already over 80 people joined in, so very happy to see that. It means there's people who want some advanced material. Now, the first thing I'm going to do is kind of walk through the what's new in 760. We just did a major update to the course, and that's kind of where we came up with this idea to run a contest alongside of Hexray. So I'll talk a little bit more about that. And I've got my partner in crime here, Huáscar Tejeda, who is one of the contributing authors of day 2 now in 760. And again, I'll talk briefly about that. And I also had the opportunity to have Jamie Geiger, who works at Grim Security, do an entire rewrite of day 4 on the kernel day. So I needed a little bit of help on this particular update with all the other responsibilities I have with giving the course the love that it needed. And it's just great to have a good team come together and kind of see this vision through. So what's new in the course? And I know no one loves sales pitches, and that's not what I'm doing here, but I know some folks do join in, and I get a lot of DMs and emails asking, you know, am I ready for the course? What should I do to prep for the course? What's new in the course? So I find that this is a great way to kind of spend a few minutes just sharing that information, and then we'll get to the good stuff, which is Huáscar taking us through the challenge for the bulk of this. So some of the key highlights, there's obviously more highlights than this, but IDA Pro is now bundled in with the course. And the reason we did that, because you might ask, well, why not Ghidra? Why not Radar 2? Why not Binary Ninja or Hopper? And that's a great question. Everyone's got their preference. I think for me, it's familiarity. It's a personal choice. Everyone I know working in research here in Silicon Valley and such still uses IDA. I've had some problems with other tools like the UX maybe I don't like so much, or the lack of symbol support or debugging support, and just different issues that come up. And I wanted the course to be seamless, and so therefore we decided to bundle IDA Pro into the course. So when you sign up, you'll have to let us know that you're okay with us sharing your information with Hexrays so that a license can be assigned to you. But hopefully that's good news. The update majorly focuses on, of course, IDA 7.4 that's been out for a couple months now throughout the course. There's a new Linux heap exploitation section, which Huáscar will take us through some of that coming up here shortly. As I mentioned, Windows kernel exploitation day has been completely rewritten for Windows 10, and we also provide you with the Windows 10 build. I believe we're on 1903 right now that you'll use for kernel exploitation. And a lot of folks ask, can I bring a Mac? Do I have to have a Windows PC? You can bring Mac. You'll just be doing VM networking debugging across between 2 Windows VMs. So works completely fine. You don't have to have Windows. But that's an exciting part, and you'll see some of the updates coming here soon. I got new patch diff targets and all that fun stuff. The most important thing that I wish I didn't leave off is that we are running this class starting on Sunday for SANS Orlando. Now, we obviously switched a lot of the conferences over to virtual training due to the coronavirus, but we are running that starting on Sunday. And the reason I bring that up is because I will be recording this for OnDemand. I've had a lot of folks over the years say, why can't 760 be in on-demand format so that you can take it at your own pace? We are finally doing that with this recording and then some additional recordings the following week, so that will be available. There are reasons why we didn't go that path previously. One of those reasons being difficulty in supporting remote students with such technical content, but now we've got subject matter experts who are going to be available to even use Zoom across Slack to get onto your system and share a desktop and help you out. I shouldn't say get onto your system, but sharing your desktop. But with Zoom these days, with what's in the news, well, who knows, maybe. So quickly, the daily outline here. Book one, so we're calling it book, even though we used to refer to these as days. The major thing here, because I have had some folks DM me today saying, can you explain a little bit on if I took 760 2 years ago, would I benefit from taking it again now? The big changes again, IDA is now bundled in, so you'll have that to go with. I rewrote the IDA Pro section in day one because obviously with IDA 7 coming out, there's been a lot of changes. I based the original day one off a lot of what Chris Eagle put into his book, the IDA Pro unofficial guide and its classes from Black Hat, and just worked it out done. So now that's been rewritten and it's all up to date on IDA 7.4. But the rest of it's really focused still on Windows Defender Exploit Guard and really looking at the modern protections and different third-party products out there like Bromium still, if we look at that, or Polyverse. There's a bunch of them out there that do some really interesting things that obviously Microsoft has been keeping up with and advancing on their own with sandboxes and isolated kernel and all those fun things, or secure kernel mode. So book two, this is the Linux section. Now, I will admit that section started to get a little deprecated. It was still really good stuff, but not a lot that you'd find on modern systems. And that's where I had Huáscar come in, and he's been working on a great tool called HeapMe, and really helps visualize what's going on in the heap. And one of the exercises and techniques that we go into in that course day is what he'll be walking through here shortly. So book three, that's pretty much consistent with what it used to be. I really wanted to have a day focusing on binary diffing with one of the ones I put in there recently. You can see it towards the bottom, CVE 2020-0601, and that was the crypt32 vulnerability with Microsoft. And we go through diffing that one, and it's a really fascinating and good way to find out how Microsoft or other vendors fixed bugs, fix vulnerabilities, and it allows you to do two things. One, you can weaponize vulnerabilities before companies patch them because organizations aren't great at patching, especially with what's going on now with layoffs and things like that. I mean, that kind of security goes out the window, sadly. So being able to weaponize a vulnerability that's been patched quickly, super beneficial and almost as good as a 0-day at times. And the other big benefit is by understanding how Microsoft or other vendors patched bugs at the assembly and pseudocode level, you can go and hunt for bugs that are relative. So we kind of go through that process. And then in book four, that's the rewrite of the kernel day. And as you can see, we go through CVE 2018-19320, and we look at reversing a driver, how you do dispatch table overrides and token stealing and all that fun stuff, but on a modern Windows 10 system, as well as getting into the kernel mitigations. Book five, the main focus on that day really gets into like client-side application exploitation, so browser-based exploitation and like Adobe product exploitation, big commercial applications that most organizations run on their client systems, and bug types like type confusion and use after free, and how we chain together multiple exploits to accomplish a goal, like a memory leak combined with a remote code execution bug. And then CTF day is book six, I guess you could call it. The final day is a capture the flag challenge, where you'll take all the different things that we cover in the course and kind of put your skills to the test there. So that is pretty much the gist of what's new in the course. And like I said, I didn't want to take up too much time, but what we did with this challenge is I went to Hexraise and said, I would like to, for SANS Institute, to buy a license and award it to the first person that gets through a challenge that we put together. And that's the one I worked with Huáscar on that he's going to walk through. And then we have another license. I was going to give it away at a live event, but I'm not sure how I'm going to do it yet. But I'll figure out a way, and I'll tweet how we're going to give away a second full IDA Pro license in the coming weeks here. But the challenge again was you need to go and download a binary and then exploit it and exploit a remote system. And there's some really neat things that you needed to do that Huáscar is going to take us through now. So with that, I'm going to go ahead and pass over control to Huáscar. And if you do have any questions, please do type them up in the chat and we can get to those at the end.
Okay, thank you, Steve. Thanks everyone for attending this webcast. So now we're going to do a walkthrough on how to exploit the baby heap IDA giveaway challenge. But before we begin, I would like to start with a quick introduction to what Heap is and how the allocator works. But I'm not going to get into too much detail because it's too much material for such a quick a challenge walkthrough. But what I'm going to speak about is relevant to the key information you need in order to solve the challenge. And we begin by the real basics on how the memory is, what is the layout when you launch a program. So yeah, we begin with code segment, data segment, BSS, and then we reach the heap segment. And this line that separates the heap and unallocated memory is called the wilderness. We also call it the top chunk. And whenever the program needs more memory, when you're using malloc, realloc, there are system calls like SBRK or mmap, depending on the size and many other factors that might be used internally. So the basic units of allocation, whenever you allocate memory, is in libc or ptmalloc2, is called the malloc chunk. And on the right, you'll see the diagram, just explaining a little bit how it looks like in the memory. So we have the first, when the chunk is allocated, the first field that you will see is the pref size. And this is the size of the previous chunk if the chunk is freed, if the previous chunk is freed. But if the previous chunk is used, this is used as user data. Then we have the size of the chunk, of the current chunk, and together with the size, the least significant bits are used for flags. So these flags can be P, which is previous chunk is in use or not, M for if the chunk was obtained using mmap, and A if the chunk belongs to the main arena or a thread arena. We're not getting into too much detail on how threads or how arenas works, but then we have the user data, which is up until the next field or the next chunk, which is the pref size again. So when the chunk is freed, the same structure, there are a couple of data structures that it points to. It depends on the chunk size and also many other factors. But let's say based on this structure that you have forward pointer and backward pointer added to it. In some cases, the backward pointer is not used. In others, they are. And it depends also on the size. They will use what we call bins. So the allocator doesn't return memory to the operating system as soon as the program frees the memory. But what happens is that it tries to reuse these memories really fast in order to optimize. Otherwise, it will be too slow for the program. Now, what is relevant for this challenge, when we speak about normal bins, you have also fast bins, but they're not being used for this challenge. So unsorted bin is another optimization used by the allocator. Whenever you free memory that is larger than a fast bin or a Tkach that I'm going to discuss after this, is going to the unsorted bin. And this is the allocator giving a second opportunity to this particular free chunk to be reallocated again for the program. And if the program doesn't use it because maybe it's requesting a chunk that is too big or some, then it might decide to sort this and send it to the small bin or to the large bin. So normal bins are doubly linked lists, small bins, and also Tkach bins are singly linked lists. Now, when we speak about Tkach, and this is really important for this challenge to understand how they work. Tkach were introduced in libc 2.26 to improve performance. And if you dig deeper into how arenas work and the limitations they have, especially when programs try to launch more threads than they should, then Tkach is really helpful in terms of performance and optimization. But what happens with Tkach is as soon as it was introduced, most of the security checks of libc were bypassed. So it was really easy to hack Heap again when Tkach was introduced. On the right, you can see the definition, and you can find this in the source code of libc. So by default, the Tkach has a maximum number of 64 bins that can allocate. And for each index, depending on the size, you can allocate a maximum number of 7. So this is really important to understand how every detail of the heap works, because this is what you're going to use in order to bypass it or hack it. You can get creative on it as well. And then you see the Tkach put, Tkach get used when you free or allocate a chunk. And if you look carefully, you'll notice in Tkach put, there are no validation checks. It just adds the chunk when you free it. It's not checking for the size, if the size is right or not. And also in 2.28, they introduced this double free protection or detection. And what they do is basically they add this chunk as soon as you add it to the Tkach put or to the Tkach table, it will add it to the key of a list of entries. If you try to free it again, it will raise an exception or crash the program. And you can see in this revision or in this commit, you can see when you call free, how it does the checks here. So if you find a way to bypass this detection, or if a free chunk is actually freed and there's a way you can bypass this assignment, then you will successfully execute a double free attack. Okay, the tools I'm going to be using for this write-up is our Pwn tools. Is a CTF framework. It's really good for if you use it as an exploit development library as well, because it has many utilities that you can just focus on the important stuff of writing your exploit and use all these utilities to help you gain a lot of time as well. We're also using the One Gadget tool. So One Gadgets are, as their name says, is one single gadget that allows you to do execv bnsh. So you can get remote code execution by calling a single gadget. Instead of trying to do a route chain, you can also do that. But this will just save a lot of time for you, especially if you're playing on CTFs. We're also using the libc database because heap exploitation is allocator specific and also version specific. The first thing we need to do before we even think about exploiting the heap is finding out what is the allocator that is being used remotely, and also what is the version of the allocator that is being used remotely. And after you have that information, then you can see what is the strategy for you to exploit it. And the last tool I'm going to use is HitMe, and it's, as Steven Sims says, this is a tool that I wrote to help studying the heap exploitation in general, the visualization, and also you can go back and forth and see every time you do an allocation how it changes your layout. It's also really good for collaboration if you have multiple people trying to understand what's happening with a particular program in terms of heap management, and especially if you're writing your exploit. And it's also really good for CTFs. It helps a lot on the communication, especially on complicated programs. Now, speaking about the challenge itself, only one binary was provided. That was the SEC760 baby heap. That's a 64 bits ELF strip binary. And if you see all the protection, it was compiled with everything, right? So you see the only one that concerns us, especially when we speak about heap exploitation, is reallocation read-only, full railroad. So what it does is that it marks the global offset table as read-only. So we're not able to overwrite any GOT address. That's really bad for us. But there's a way to bypass this protection. And if you see a functionality from the allocator, they're called hooks. And mainly the malloc hook, realloc hook, free hook, they are there to help developers probably change the way the allocator works. And also for debugging programs, it can be used a lot. But then we can abuse it because every time we call free or malloc, these hooks are being executed. If we find a way to overwrite one of these hooks, then we might execute our gadget successfully. And then there are two ways of solving this challenge. The first one I'm going to speak about is the off-by-one vulnerability, which is the intended way. And I'm also going to show how to exploit this binary using a double free vulnerability that is present there. Okay, so the end goal for us is the Tkach poisoning. And this is on the step 5, this is how it should look like. What you want to do is override the metadata of a chunk that is already in the Tkach, making the allocators think that there's an extra chunk in the Tkach, and if we return it, we're able to overwrite whatever is there. So the first thing we're gonna do, especially for the off-by-one challenge solution, is allocating 3 chunks. The size doesn't really matter, as long as what you need to be careful is that they need to be aligned. Otherwise, you won't be able to do the off-by-one or to modify the metadata or the least significant bits of the next chunk. So the size is really important, but they just need to be aligned and be part of the Tkach, which is the attack we're launching. Then we free chunks 3 and 1. The 1 is the last chunk we're going to free because Tkach is last in, first out. And what we want to do is to abuse this first chunk in order to write one more byte than we should. And we're going to show how it works in a few minutes. And once we do that, if we free the second chunk will now have a larger size. But the allocator is not aware of what happened because it was a vulnerability caused by a validation, or the programmer wasn't careful enough when the user was entering data. So it allowed the attacker to write one more byte than it should, then allowing it to overwrite the next chunk's metadata. And once we have that, we can write to this new chunk, and we modify the forward pointer of the chunk that is currently in the Tkach, allowing us to overwrite free hook. And if we call free again, then we might execute whatever is pointing there. Okay, it's time for the demo. So I'm going to open my terminal here. And this is the binary that was given to us, right? So if we confirm everything we saw earlier, it's an ELF binary stripped. We can also check the security. Yeah, it has all the protection on. We can keep digging, looking for information about it. If we do strings, for instance, we might see that a menu here. We also see that it has a proof of work. In CTFs, proof of work are well known because they are mainly used to avoid brute forcing or fuzzing to the remote service of any type of denial of service remotely. So they ask you to solve a challenge. And as soon as you solve it, then the actual challenge begins, CTF challenge. So before doing dynamic analysis, let's disassemble this program. I love to do that in every CTF, especially every challenge, because it helps me gain time, understand how the binary works before I start playing around. So when we open the main function, I marked every function and every line that was interesting just to gain some time. And here, when we open it, this is the proof of work that we saw earlier. Yeah, it's as you can see, it's lowercase alphanumeric. It's using time as a seed for the randomization. Then if we can keep going down, we see that there's a string compare. And if we open with ltrace, we can see the string compare here, but also string length. So if we enter this or whatever else, we might see the string compare right here. Okay, so we keep analyzing it. After this, we see the menu that we saw earlier using the strings. And there's a switch. And we can start looking at the different cases for this switch. So the first one is login. And we see here, let me zoom in a little bit. So we see there's a username and password that is requesting from us. It's also doing a string compare. And the hash is there's a hash being generated when you enter the username, similar to a serial number. Then you have the info. And the info is really interesting because there's free hook right here. Remember what we discussed earlier. If full reallocation read only is enabled on this binary, we need to leak free hook. But in the case of this binary, free hook was a gift from the creators because we just need to leak this. Now, when when the binary is printing the current user, you don't see any format here. So info might be vulnerable to a format string attack, and we might use it to leak this free hook. So this is half of the battle, and we already have it. Then we have a create and delete. If we see create here, create is allowing us to allocate a maximum number of 15 chunks. So uh, whatever decision we take on what is the strategy for exploiting this binary needs to be less than 15 chunks. So if we go to the read, when it's reading the size and later the data to assign to this chunk, you can see here that it's vulnerable to an off by one. So it reads one more byte than it should, and it copies that to the chunk. This will allow us to modify the size of the next chunk, and we'll see that in a few minutes. And then we have the delete. It's a normal delete. Yeah, it's comparing if the chunk you try to delete is higher than 9, then it doesn't allow you to do that. So this is part of the strategy that you need to come up with that doesn't get stuck by one of these checks. And then the final one is just to exit. Okay, with this knowledge, what if, since we know that the string compare is being used, we can do it in multiple ways. We can first, if you just want to analyze this binary without starting to write our exploit really quickly, what we can do is look at the definition for string compare, and we can hook using LD preload. Let's create a quick binary here using the same definition, and we're going to return 0. We compile this, shared, and we execute it with LD preload. Whatever we enter here is going to be fine because the string compare will always return 0. That allows us to play with the binary, really simple, in a really simple manner. Remember, the info function was the one vulnerable to a format string, and it's printing the username that I just used for login. So let's log in with a %p, whatever password. You're logged in now. If we print it, yes, it's printing some address here. Now we need to confirm if this is actually free hook. So we're going to open our debugger, and we're going to check this address. And yes, this is definitely free hook. So the next step would be to start writing our exploit and being able to execute exactly the same thing that I just did on the remote host. Unfortunately, I cannot do LD preload on the remote host. So we're just going to leak this free hook remotely and confirm which libc version is being used remotely. So let's start writing our exploit here. Again, I'm going to be using Pawn tools. First, I'm going to import all the libraries that I need. Pawn tools, string, iter tools, and since I need to solve the proof of work with SHA-256, I'm importing this one as well. Then I specify Pawn tools, what is the context. And in case I want to launch GDB from Pawn tools, I also need to specify which terminal I'm going to use. After this, I specify the process, the program I'm going to be running. And I like to separate everything in functions because later I can just reuse them really quick. So the first function we're going to create is the proof of work. We read until equal space and receive the challenge. And this is how Pawn tools is really helpful in interacting with these binaries. So I create an alphanumeric string. I use iter tools I saw earlier that the amount of byte that it's using to compare is 4. So I just iterate through this until I find a valid hash. Once I find the valid hash, I send it. So let's see if it actually works. And later I'm going to tell PwnTools to give back control to me of the program, of the output of the program, input and output. If I run it, it solves the proof of work right away. And now the next thing I need to solve is the login. Since I saw the hash when I created %p before, I just create a login, send one, send the %p and the hash, and I should be authenticated. Okay, now I'm logged in. If I print 2, if I use the second option, then the free hook will be leaked. Now let's do that before we move forward on the remote host. And this is also, you can see how helpful PwnTools is. You just need to say remote, the address and the port. And let's try to do that again. We're logged in. Now we're able to leak, and let's use libc database in order to find out libc database to find out what is the libc version being used remotely. So we know it's free hook, and we have the address. It will tell us that this is libc 2.29, the remote system. So we can find this in the libc database as well and copy it to a local folder. So now we have the libc that is being used remotely, and we can also open the libc locally. Now the next thing I'm going to do is to write a function that will allow me to parse this leaked address, because what I want to do with this libc is to calculate the distance between the leaked address and the libc main, or the libc base. And by calculating the base of the libc, then I might be able to execute any libc function. In our case, the one gadget. So this is the next function is leak, and leak is going to return the parsed leaked address. Free hook is equal to leak. And after this, we can calculate the address of libc base is equal to free hook minus libc symbols free hook. And once we have that, we can start calculating many other stuff. Now, what I'm going to do right now is to print this out using log info. And when I run it, this should all match. So let me confirm I'm executing this in the local binary, not the remote one. I run it again, and then I can see the free hook was leaked, and also I calculated, let's see if I calculated this correctly. So we open GDB again. Let's confirm if the addresses match. This is free hook, this is fine. And then the next address should be equal to libc base address. So we use VM map. We can also use info proc mappings, but this one is more colorful, easier to read. This is the libc base, and we can see it's the same address. Okay. So the next thing, now that we're done, we already know what is the remote libc running remotely. We also know the leaked address. We calculated the base. Now it's time to exploit the heap. Let's create 2 more functions that will allow us to create and delete chunks. All it's doing is in create is executing 3, setting the size and data, taking them from the argument, and deleting the index that I also pass to it. So it makes it really easy for us to exploit. So as we saw previously in the slide, We first going to create 3 chunks. And the three chunks I'm going to use 58 hex, A, B, and C. And the index is important just for quick reference because we need to delete the indexes in the correct order. So we first delete the second one, then we delete the first one because we're going to use that to overlap or to abuse it with the off by one to change the least significant bit of the B chunk. So we delete second one, we delete the first one. And now if we write another chunk, same size, but we add a new size, a new byte, and let's call it FF. Let's see how it looks like. Hold on, before we go there, I would like to run GDB directly from Pawn Tools so that I don't have to go back and forth. So let's have it here. Let's see how it looks like. GDB, sorry. It's opening our debugger. So we let it run. And we see, I'm using Jeff as a utility here. So if you look at heap chunks, you can see the layout. The only problem with this is that you need to, you don't have full visibility of what's going on there. If you look at the heap bins, you see there's something in the Tkach, but if you want to have a bigger look, then you would need one of these addresses. And as you saw, we created 3 chunks, A, B, C. We freed the third chunk, the first chunk, and then when we allocated it again, then we could actually modify the least significant bits or the size field of the next chunk. But using GDB like this over and over is really complicated. I mean, you could do it. That's the way we have been working for years with heap exploitation. But let me show you how HitMe looks like when we try to exploit this binary. So first we go to the HitMe website, hitme.f2tc.com. You create your account, you're logging, and then I can say, I'm going to create solution 1. I copy this address and I add it to my Pawn Tools attach as a GDB command after heap analysis helper. And if I run it again, you can see HitMe is there. If I click next, continue, you'll see what happened here. Exactly the same view we saw before, but now there are a couple of utilities that will help us visualize faster whatever we're doing here. So we created 3 chunks. We freed the last one and the first one. Hold on, I made a mistake here. So we need to delete the second one and the first one. You saw how easy it was to see in the HitMe. Okay, continue. If I refresh, let's go for it again. Okay, it's hold on. Sure. Everything is cleared. I run it. There we go. So I allocate 3 chunks. I freed the last one and the first one, and then I modify the size of the second one. Now, if you see when you allocate, that's normally what you see in Jeff or in any other utility for heap exploitation as well to help you. There are things that you won't see because it happened after the allocation itself, which is the case. So we called malloc, and then we copied the data over this chunk. So one way to solve this or to visualize this in HitMe is to disable ASLR, and you can run your the program. You hold on, let me run that again. You open GDB once again, you step over, and if I execute an invalid index, it will print that to the screen. And later, what I'm looking for is a mess when the menu function is executed, invalid choice, and then it executes our menu here. Let's confirm that, yes. So whenever this menu is printed, I also want to update all the chunks. So I tell HitMe to watch this address. Whenever this breakpoint is hit, it will update all my chunks. So let's run this again. We refresh it, continue. Now we have a lot more hits. So if we go back, we have the 3 chunks aligned. One is in the Tkach. The second goes to the Tkach again. And now I'm going to create one. And you can see here that I modify the size of the second chunk. So what we're going to do now is to overlap this chunk that is in the Tkach and poison it by modifying this forward pointer, what is supposed to be forward pointer. Right now is 0, is null, because you don't have any other chunk in the Tkach. But now we're going to change that. So one utility from HitMe is that I can select a range, and it will tell me how many bytes I need in order to bypass it, or to how many bytes I need to overlap this chunk. Okay, 70 bytes in order to have a chunk this size. So instead of FF, we're going to pass 70, and we need to pass 71, because 1 would be for the pref chunk is in use. Okay, so let's do that. Instead of FF, we pass 71. And now, if we delete this chunk, we're going to have a chunk of this size. This is our overlapping chunk. And what we want to overwrite is the forward pointer. So we could use that. And that's the number of bytes that I need to write in order to bypass it, is 60. We can also use the cyclic function and use pattern create as pattern create, pattern offset, as normally everyone uses in PEDA or even Jeff or any other utility like that. So using HitMe, we know that is hex 60. So we create a new chunk, 68. That would be the 70 minus the header, and 60. And after this, we're going to write here the address of the free chunk. Free hook, sorry. If we create a new chunk, and you'll see that now, it will be returned from the Tkach the address of free hook that will allow us to write whatever we want there. So let's create another chunk of the same size and in the Tkach, so that it takes this chunk from the same index. And let's override this address with P64 dead beef. Now, what we know is that free hook will be overridden with this dead beef address. So if we call free again, it will execute this free hook, which in turn will execute this address. So let's run it. It will ask me to override HitMe again. I execute all that. Jeff with the heap analysis helper, is detecting the use after free here. Then it detects the overlap. And you see it crashed. And look where rib is, dead beef. So it's actually executing what we want. We can get remote code execution. The final step now, and let me show you before that how it looks like. So as soon as I freed, I have enough space, and let me put that a little bigger. I have enough room to overlap this chunk that is currently in the Tkach. You can see that here. Right. The chunk is right over here. So in the next step, I free and I create a new chunk with the address of free hook. And when I request a new chunk, the same size, in the same index 4, it will return free hook, and this will allow me to override this address and execute. So the final step would be to get the one gadget. Let's use the one gadget utility. And it will get all the different gadgets that it found in this libc version. And you can use this in a couple of ways. One of them could be you just try them all and see which one actually works on the remote host. But every gadget, as you can see, has multiple constraints, and we need to make sure that we meet all these constraints in order to execute correctly. So let's take the first one and let's try to run it. So let's create the one gadget and calculate the offset here. Sorry. One gadget is equal to this address plus the libc address, libc base. And let's also print that out, because we're going to use that to set a breakpoint and make sure that we can actually see that in our debugger. Let's exploit that again. Let's run it again. Yes. Okay, so let's hit continue. And when it stops, let's get this address and set a breakpoint. And continue executing. As you can see, we're finally here. So this is our breakpoint. Now let's confirm if all these constraints are met, if it actually will succeed. So the first gadget is telling me that RCX must be equal to null. That's true. RBP must be equal to null as well. RBP minus 70 hex. Is not null. So that one gadget will not work in this case. So let's go to the next one. RCX, we know is null. RDX must be null, is not. So we move to the next one. RSI must be null. Oh, sorry, RDX. It's not null. RSI is not null. And the last one, RSP plus 70 hex. This one is null. So this is the only one gadget that will work for us in this situation. So let's run it now. Let's replace the one gadget we have earlier with the one that works. And let's run it without the debugger. We should get a shell. There we go. So the final step would be to do the same in the remote host to read the flag. And then we have it. Remote code execution, thanks to a lack of correct validation and allowing us to do an off by one. That's what happens in the heap. If you want to see how it looks like, in HitMe, the final exploit, let's run it one more time. So we refresh here. We start running it. Heap analysis until we execute our shell. And this is how it looks like in the end. Okay, so you can go back and forth. You can share this address with whoever. After this webcast, we're going to share these links so that you can go through them carefully, one by one, step by step, and try to reproduce if you haven't done so. Now the second challenge, the second solution for the same challenge is abusing the double free. So let's copy the hook and let's demonstrate where the double free vulnerability is. Okay, so if we, let's log in. If we create one chunk, any size, and we try to free it 2 times, then we get double free detected in Tkach 2. This is what we saw earlier in the commit for the allocator. So this is, the program has no protection for double free, and it's the allocator that is crashing, trying to protect the end user. So the solution, and let me copy the same exploit and leave C because I don't want to go over it again. So the solution in this case is, remember when we spoke about Tkach and we said that the Tkach holds by default a maximum number of 7 chunks. So what if you free one chunk, because if the Tkach is full, you free it and then it goes to the unsorted bin. The Tkach doesn't even analyze it because it's already full. You could use that because you could use that to free it again once the Tkach is no longer full, because it won't keep track of this particular chunk. So let's try to do that. What we're going to do is, first, we're going to create 7 allocations. These allocations will later, when we free them, they're going to fill the Tkach. So they go from 0 to 6. Then we allocate another chunk, which later we're going to use to consolidate our victim chunk. We're going to call it the previous chunk. And then the victim chunk, which is the one we're going to exploit. And one last allocation for padding, because we don't want top chunk consolidation. If we don't have that, then we'll also consolidate with the top chunk, and this will, we're starting over, nothing will work. So we're ready to create the chunk overlap using the double free vulnerability. We first free the first 6 chunks. We delete the victim chunk first, 8, because remember, normal beans are first in, first out. We want to keep that in mind. And later we free the previous chunk. And with that, we will have everything set up to make some room in the Tkach that allow us to free the victim chunk once again. So we make some room. Now the Tkach will no longer be full. And if we delete 8, we will not get a crash from the Tkach because it was never there in this list before. Okay, so once we have that, we will have an overlap. Let's see how it looks like in Heap. I'm going to reuse the same address as before. Okay, let's refresh. Continue. You can see all the allocations that are being done. Then we free them all again until we reach the unsorted bin. But now I'm going to explain using HitMe what's happening. Okay, we have it. Now, first, we do all the allocations. Then you can see how the count in the Tkach starts increasing until it's full. When it reaches 7, the next free will not go to the Tkach, to this index, because it's full. It will go to the unsorted bin. There you have it. Now, the one we freed was the victim chunk. Now we're going to free the previous chunk, previous from the victim. And you can see this one is in the unsorted bin. Now we'll go to, this one will go to the unsorted bin as well. But as you saw here, they got consolidated as a single chunk. And now the size is 220. So if we create a chunk, remember this was already freed, right? It was in the unsorted bin consolidated and we freed again. And it actually worked because this guy thought, it's not in my list, so there's no problem. I can free it again. I mean, there's no tracking on double free right here. So we can go once again to, what are we going to overlap now? We're going to overlap this chunk that is in the Tkach because we freed that again. It's right here. Okay, but we also have enough space in the unsorted bin to overlap this chunk. So how many bytes should I write? Okay, it's telling me at the position 110, I can write my free hook. So, let's just get lazy and I'm gonna create one chunk big enough to use this unsorted. Let's say 200 hex. This is going to be F, but we know that at 110 hex is where we want to write our free hook to override it. And this again is similar, is the same, different way of doing an overlap, but it's the same end goal, which is poisoning the Tkach, modifying this this chunk and making it think that free hook is part of the Tkach, which is not, right? So 110 plus free hook. And if we create again, it's going to return the free hook. And if we write to it our one gadget, we will get remote code execution. Let's see if it actually works locally. Oh, invalid choice. Let's see what I made wrong here. So 200, I place it here. Let's see how it looks like in Jeff. In HitMe, sorry. It's doing its magic. Overlap detected. Let's see what happened. So this must be part of our free hook as well. So we create 100, delete, this is the double free. It's funny. Our one gadget. Okay, for some reason I missed something right here. So let's confirm that I have everything correctly. Go range, create my two chunks. Then I add some padding here. I free them all. I delete 8 and 7. Create double free. Okay, before that, let's use cyclic to understand what's happening here. I'm very sorry, this is live. So we continue. Let's do it again. Okay. Something crashed here, and I have it. So what we wanted to overwrite was this Tkach, this address. So we can use this to look for the pattern. Pattern search, sorry. And 272, that will be 110 hex. So it is fine. Let me check something, because we don't have time. Maybe when I was speaking, I didn't look carefully enough. Let's see the same solution again. Same allocations. Yeah, something I messed up. I would I would need to see step by step. You know, since I was writing and speaking, maybe I confused it, but the strategy is actually the same. And then let's run this on the remote host using double free. There we have it again. Okay, so we're going to do also a write up on this, and you can also see the slide later, or the presentation later, the webcast. But that's basically the two ways to solve this challenge.
All
Great,
right,
thanks,
so
Huáscar.
thank you. That's all the time that we do have, unfortunately, for this webcast. But thank you again, Huáscar and Stephen, for your great presentation, which helps brings this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcast. Until next time, take care, and we hope to have you back again for the next SANS webcast.